Today we will discuss the concept of chain rule in differentiation. So if fx and gx are differentiable functions, then the composition of f and g, that is FOG, is also differentiable, and the derivative of the composition of f and g with respect to x is given by the derivative of f with respect to the function gx multiplied by the derivative of g with respect to x, right? So viewers, here we'll discuss some important problems related to chain rule. Now this expression can also be written as here we have d by dx of the composition of the functions f and g is equal to the derivative of the composition of f and g is equal to the derivative of this function, that is FOG of x with respect to gx, and then we multiply it by the derivative of the function g of x with respect to x, right? So let us take some important problems. Now suppose we have to differentiate this function with respect to x. So what we will do, we'll take this x square plus 4 as u. So we'll put u is equal to x square plus 4, and let y be equal to sine x square plus 4. Now we'll differentiate this function u, which is a function of x. So we have first the derivative of u with respect to x, that is equal to 2x, and now we have to find the derivative of y, that is this function with respect to x. So dy over dx can now be written with the help of this expression, that is equal to dy over du, because now this function becomes sine of u, right? So we have dy over du, and then we'll take the derivative of u with respect to x, right? So what is dy over du? So obviously the derivative of sine u is cos u, and here the derivative of u with respect to x is 2x, right? So we have 2x cos u, and this is equal to 2x cos, again we'll resubstitute the value of u, that is here x square plus 4. So this is the required derivative. Now let us differentiate e raised to cos x with respect to x. Now let us take y is equal to e raised to cos x, and let us put u is equal to cos of x. So this function now becomes e raised to u, and let us find the derivative of u with respect to x, that is minus sine x, right? And now we have to find the derivative of y with respect to x. So we can write it dy over du, because first we have to differentiate this function with respect to u, and then here we have du over dx. Now dy over du is the derivative of e raised to u with respect to u. Here we can substitute its value, and du over dx is minus of sine x, and here we have e raised to u times minus of sine x, and let us resubstitute the value of u as cos x, so we have e raised to cos x multiplied minus sin x. So this is equal to minus sin x e raised to cos x. So this is the required derivative. Now let us differentiate this function with respect to x. So let y is equal to log of sin x square. So here what we will do, we'll take u is equal to sin x square, right? And v is equal to x square. Now this function becomes log of u, and we have to find the derivative of y with respect to x, right? So let us first find the derivative of u with respect to x. So we have here assumed v is equal to x square. So here u x square can be written as v. So we have u is equal to sin v, right? So du over dv is equal to cos of v, because the derivative of sine is cos, and the derivative of v with respect to x is 2x, right? Okay, so now we have dy over dx. So dy over dx can be written as dy over du. Then we have du over dv, and then we have dv over dx, right? So now dy over du is the derivative of log u with respect to u, and du over dv is cos of v, and dv over dx is 2x. Now this is 1 over u, and this is cos of v, and v is x square, and here we have 2x, and for u we have sine of x square, and this is cos of x square times 2x, and cos over sine is cot of x square times 2x. So this is 2x cot x square, right? So this is the required derivative. Now let us differentiate this function with respect to x. So let y is equal to x square plus x plus 4 raised to power 4. Now here let us put u is equal to x square plus x plus 4, so that this function now becomes u raised to 4, right? Now here we differentiate u with respect to x. So we have du over dx is equal to 2x plus 1, and the derivative of 4 is 0. Now we want to find dy over dx, and this can be written as dy over du times du over dx. Now dy over du is the derivative of u raised to 4 with respect to u, and du over dx is 2x plus 1. Now this is 4 times u raised to 3, and this is 2x plus 1, and again substituting the value of u here. So we have x square plus x plus 4 raised to 3 times 2x plus 1. So this is the required derivative. Now let us differentiate this function with respect to x. So let y is equal to sine inverse square root of x. So let u is equal to root x, and let us find du over dx, and du over dx is equal to 1 over 2 times of root x, right? So this is du over dx equal to 1 over 2 root x. So here we have applied the formula, that is x raised to n. The derivative of x raised to n is nx n minus 1. Now y becomes sine inverse of u, and therefore dy over dx is equal to dy over du times du over dx, and dy over du is the derivative of sine inverse u, and here for du over dx we can write 1 over 2 root x, and the derivative of sine inverse u with respect to u is 1 over square root of 1 minus u square, and here we have 1 over 2 times root x, and here for u we can write root x, so this is 1 over square root of 1 minus root x square, and this is 1 over 2 root x, and this is equal to 1 over square root of 1 minus x, and here we have 1 over 2 root x. So this is the required derivative. Let us take this problem. Here we have to differentiate e raised to cos of x cube plus 2x plus 4 with respect to x. So let v is equal to cos of x cube plus 2x plus 4, and u is equal to x cube plus 2x plus 4. Now this expression becomes y is equal to e raised to v. Now we have to find dy over dx, and this is equal to dy over dv. Then we differentiate v with respect to x, and it is with respect to u, and then we have du over dx, right? So here we have assumed v is equal to x cube plus cos of x cube plus 2x plus 4, and u is x cube plus 2x plus 4. So therefore v becomes cos of u, right? Okay, so now dv over du is minus of sine u, and du over dx is 3x square plus 2. The derivative of x cube is 3x square, and the derivative of x is 1, so we have 2, and the derivative of 4 is 0, right? So now here dy over dv is the derivative of e raised to v with respect to v, and dv over du is minus of sine u, and this is actually u, and du over dx is your 3x square plus 2, right? Now the derivative of e raised to v with respect to v is e raised to v, and we have minus of sine u, and this is 3x square plus 2. Now this is minus this is e raised to v, and v is cos of x cube plus 2x plus 4, and sine u is sine of x cube plus 2x plus 4, and then we have 3x square plus 2. So this is the required derivative.